This is just review from yesterday. Now, remember what I told you. I told you that on your test, I'm not going to let you use Desmos for the whole thing. All right, so you got to know how to do it by hand, or you got to know how to use a TI to find it. So I'm about to show you how to find it in a TI. All right, but we're going to do the by hand first. Okay, because remember what I said, that test, which won't be till like later next week, that test will be like 3/4 no Desmos, fourth Desmos. All right, so you can't use Desmos as a crutch. So first off, what I say you always got to do with these before you start anything. List A, B, and C. So A's what? 3. What's B and C? 0. So there's no X and no constant. You just put 0 for them. What's my y-intercept? 0, 0. Where do we get it from? What? The C value. Good. Axis of symmetry. This is the formula right here. It's negative B over 2A. So I do negative 0 over 2 times 3. So that's 0 over 6, which is what? How do I write that? X equals 0. Remember, when you're writing axis of symmetry, if you don't put that X equals, you're getting points taken off. That's also the X value of our vertex. Now, to get the Y value of your vertex, you just plug that 0 back into the original equation. 0 squared 0, so 3 times 0 is just 0. So that's my Y value. So that one was easy. All right. Let's look at number 2. So I'm going to show you how to do this one by hand first, and then I'm going to show you how to do it in a TI. All right. Just so you know how to do it. It'll be like a good way to check yourself if it's on the test and you don't have access to Desmos. All right. First off, what's A, B, and C? What's A? Negative 1, C, B, C. Good. What's my y-intercept? 0, negative 15. Get in the habit of writing that as a point. Axis of symmetry, I'm going to do negative 6, which is my B value, over 2 times negative 1, which is my A value. So that'll be negative 6 over negative 2, which is what? 3. So how does I write that as the axis of symmetry? X equals 3. That's also the X value of my vertex. Shh. Plug the 3 back in. Remember, if I were you guys, get in the habit of whatever number you're plugging back in, just put parentheses around it. Just so, like, for example, especially with the 3 squared with the negative in front of it, just so you don't, like, say, include the negative with the 3 when you square it, because you're technically not supposed to. So this would be negative 9 plus 18. Guys, please stop talking. Minus 15. So negative 9 plus 18 is 9. Minus 16 is negative 6. Now, let's say that you forgot how to do that and it was the part of the test that you did not have access to Desmos. Here's what you do. So do you guys remember how the other day I showed you how to get the graph out of Desmos? All right. That's what you're going to do first. So you're going to go to y equals, clear out a function if it's already in there, and you're going to type in the function. So negative x squared, what was it, minus 6x plus 6x minus 15. Did I put in the correct function, guys? I just don't have it in front of me. Okay. So is everyone able to type that one in? I would try this if I were you so you can get used to it. All right. Then, once you get it typed in, you hit graph, which is the top right button. And it should graph it for you. All right. Now, if you want to zoom out on the graph because you can't see it all you do is hit the zoom key, which is the middle of that very top row of keys. And then if you want to zoom out, just hit the number 3. Top right key. It says graph. No, just graph. You probably put a minus in instead of There you go. So you just hit the zoom out and then hit enter. All right, now to get the vertex, here's what you're going to do. You're going to hit the second key, and then you're going to hit the trace key. It's to the left of the graph key. And this should pop up. All right. Now, was this vertex a max or a min? It was a max. All right. So you're going to click 4. Now, it says left bound. So do you guys see this little blinking X right here? All right. You want it to be to the left of the vertex. So where it is now, you can just hit enter. Then it will ask you for a right bound. So you're going to use your left and right arrow keys and move it until that blinking X is to the right. Doesn't have to be perfectly to the right, but just to the right of where the vertex is. Then it asks you to take a guess. So get it as best as you can on top of where the vertex would be. It doesn't have to be perfect. You just got to take a guess and hit enter. Where's your what? Oh, you went too far. Yeah. There it is. Thank you. All right. So it says 2.99999 negative 6. So 3 negative 6. All right. So just on the right of the vertex. You don't have to go too far. I'll just go slightly to the right. All right. Did everyone see what I did there? Do you guys need me to calculate it again? So that's how you get the vertex. Now, you can also get a value. So if I hit second trace again, let's say I want a value. So I'm going to hit 1. That value specifically is the y-intercept. So what am I going to put in for x? 0. So when x is 0, that gives us the y-intercept. So if I hit enter, there's your y-intercept. When x is 0, y is negative 15. Just get it as best as you can. Hit enter. Then get it as best as you can to like being right on top of it. Doesn't have to be perfect. So that's good. Hit enter. Yeah, that's correct. All right, does everyone understand how to calculate it using the TI? We'll do another one, all right? So, again, that's an option for you if you forgot the formulas, all right? Let's try this one. So, by hand first, A, B, C, that would be 2, negative 4, and 0. What's my y-intercept? 0, 0. Axis of symmetry will go into negative 4 over 2 times 2. So that'd be 4 over 4, which is what? 1. So write x equals 1. That's the x value of my vertex as well. Plug it back in. I get 2 times 1 squared plus 4 times 1, or minus 4 times 1. So that'd be 2 minus 4, so negative 2. All right. If I wanted to check my vertex and y-intercept, go back to my TI. I'm going to go back to y equals, clear the function that I have in there, and type it in. So 2. So guys, you don't have to do this if you don't want to, but just watch what I'm doing. So 2x squared minus 4x. I'm going to hit graph. Now, because my zoom was still inactive, like I zoomed out, if I want to zoom back in or back to where it was originally, I'm going to hit the zoom key. And then where it says Z standard, that will get you back to the original. So I'm going to hit 6. All right. Now I'm going to calculate my vertex. So is this vertex going to be a max or a min? It's a min. So I'm going to hit second and then trace. And then I'm going to hit 3 for minimum. So left bound. So I'm going to move my arrow key so that it's just slightly to the left of where the vertex would be. And I'm going to hit enter. It then asks for right bound. So I'm going to go use my arrow key and go slightly to the right of the vertex and hit enter. And then my guess, I'm going to get as close as I possibly can, or that it will let me get to the vertex. So I'm going to hit enter. So it beats at 1, negative 2. All right. Check my y-intercept. That's a value. So I hit second graph. Nope, second trace. I'm going to hit 1 for value. And what do I always plug in for x for a y-intercept? 0. Hit enter. When x is 0, y is 0. So that's the y-intercept. Okay, so second trace 1. Then to put 0, enter. All right. Now, this last one. So what's my y-intercept? Y-intercept, guys. 0, 7. Axis of symmetry. X equals what? All right, let's check it because I get conflicting answers. So I have negative 8 over negative 2, over 2 times negative 2. So negative 8 over negative 4. X is equal to 2. Plug it back in. 2 squared is 4 times negative 2. That is negative 8 plus 16 plus 7. So that would be 8 plus 7, so 15. So this would be 2, 15. Any questions on those? All right, max and min. So how can I tell max and min without graphing it? Or if it has a maximum or minimum? If the A value is positive or negative. If it's positive, which one do you have? No, you have a min. If you have a negative, it's a max. So this first one would be a max because the A value is negative. Now remember, the max or min value means that, so the max or min value just means that you need to find the Y value of the vertex. All right. So you got to do negative B over 2A and then plug it back in. Now, for time's sake, I'm just going to put it in the calculator. So I know you guys should be okay with doing that on your own. So I'm going to go y equals, clear it. I have negative x squared. What's the next part? Plus 4x minus what? Minus 1. Hit graph. All right. I'm going to calculate the vertex. So second trace, we know it's a maximum, so I'm going to hit 4. Left bound is going to get slightly left of the vertex. Hit enter. Right bound, I'm going to get slightly to the right of the vertex. Hit enter. Guess be about right there. So my vertex is at 2, 3. So my max value is 3. Domain, what I say is always the domain. All real numbers or negative infinity to positive infinity. Either one of those. Range. So that's where you got to use that max value or the y value of the vertex. So the max value, that means that y value, is that going to be the largest y value or smallest y value? So is the 3 going to be the largest y value or the smallest y value? It's the largest. So if I was writing this in interval notation, would it go to the left of the comma or the right of the comma?
Right.
The right, because it goes from least to greatest. So this would be 3 with a bracket. What would go on the left side? Negative infinity. You could have also written it as y is less than or equal to 3. So I tell you guys, like, if it was a short answer question, I don't care which way you write it. But if it was a multiple choice, they may or may not give it to you in interval notation or inequality notation. So you need to be able to recognize both. All right. Last one, 6. So I'm not going to go over page 19 because that's just kind of more of the same. If you want to check your answers, the key's already posted. So is 6 a max or a min? It's a min. Why? A value is positive. So if I want that max or min value, I'm just going to put this into my calculator. So I have x squared plus 2x. I'm going to hit graph. We know it's a minimum, so I'm going to hit second trace 3. If I go to the left a little bit of the vertex, hit enter. Go to the right a little bit. Hit enter. And then go to the vertex as best as I can. Hit enter. So -1 is the vertex. So my minimum value is -1. So that's the y value of the vertex. Right, so domain's always all real numbers, so negative infinity to positive infinity, or you can just do the r with a line through it. Now, since it's a minimum, the vertex is a minimum, does that mean the -1 is the lowest or highest y value? Minimum. It's the lowest. So if I was writing this in interval notation, would it go to the left of the comma or the right of the comma? Left. Because remember, interval notation is from least to greatest. So if that's the smallest, it's on the left. Right, goes to positive infinity. You could have also written as y is greater than or equal to -1. Again, if this was on the test, guys, I don't care how you write it for a short answer. I do care if it's a multiple choice, you got to be able to recognize it in either form. All right. Any questions? All right. So for today, put the phones up. So for today, you're going to need your Chromebook out and have Desmos pulled up. Today is definitely a Desmos day. So this is going to be this particular topic that we're doing today is going to be one of those topics that you will be allowed to use Desmos on. So have Desmos pulled up and then have page 20 up and running. So what I want you guys to do once you get Desmos pulled up is on page 20, I want you to input this function, the 5x squared minus 6x minus 9, and then find all of the key features that it's asking for, except for the last two. All right. So I want the y-intercept, the axis of symmetry, the vertex, tell me whether it's a minimum or maximum, and then a table of values. All that stuff Desmos generates for you. So I'll give you guys about 2 or 3 minutes to do that because it should be pretty quick. So Desmos, and you're finding the key features of what's currently on the board. Those are all the ones I want you to find.
Y intercept is when it goes up into the Y.
When it crosses the y-axis, yes. So some of them you may not even need Desmos for. You can still use the, like say the y-intercept. You shouldn't even have to put that one in Desmos. You should be able to look at it and tell you what it is.
It's just when they cross the line.
Nope. It's the x value of the vertex, always. Don't be thrown off if you get some decimals. They're supposed to be there. Hit the gear key and then hit the table icon.
And what are the solutions?
I just said just find the 5 that's on the board so you can stop. So I just want you to find what's currently on the board. You don't need to find solutions, and you don't need to find f of x is equal to 5. Yet. You don't find it yet. Thumbs up if you're ready. Give you guys 1 more minute. All right. So let's talk about it. So in Desmos, remember, most key features in Desmos they already pre-marked for you. Anything that they deem important, they will have the point already labeled. So all you gotta do is just click on it. So for y-intercept, I look where the y-axis is, click on it. Your y-intercept is 0, -9. For vertex and axis of symmetry, they already have the vertex marked. You just gotta click on it. So the vertex is, guys, please stop talking. The vertex is 0.6, negative 10.8. So that means the axis symmetry is what? How would I say it?
0.06.
How would I?
X equals
X equals 0.6. Good. You got to remember the x equals. Is that a max or a min?
min.
Min. Now, does everyone understand how to generate the table, or do I need to show you guys? Speak now, forever hold your peace. Yeah. All right. So whenever you want to generate a table from an existing function in Desmos, you click the little gear key up here where it says edit list, and then this pops up. Then you click on the little table icon next to the function that you want to generate a table for, and it'll generate the table for you. So for that particular problem, all you had to do was copy down the table. But remember, in Desmos, you can also input any x value you want, and it'll tell you what the y value is. All right. Now, going back to the other two. Yes. It's just the x value of the vertex. You just have to remember it's the x value of the vertex. All right. So, who remembers what the synonymous name for solutions is? Zeros, which are what type of key feature? X-intercepts. So when they're talking about solutions, we're talking about x-intercepts. Remember, quadratics can have up to 2. All right. So for these solutions, I'm going to go back to my graph. Now, if you don't see the points anymore, make sure you just click on the function itself and it should generate the points again. And I'm going to go my x-axis and click on the 2 x-intercepts. Now, these are irrational numbers, so I'm just going to round them. So I'm going to say that my 2 solutions are negative 0.87 and 2.07. So I'm going to say x is equal to the set of negative 0.87. It's just one of those like squiggle brackets. I just call it the squiggle. I know there's a proper name for it. I cannot think of it, nor do I really care. I just call it the squiggle. Or the squiggle bracket. Well, you round whatever they tell you to round it to. So since we don't have anything to round it to, I usually just default to hundredths. All right, now, this last one. F of x is equal to 5. What are we actually looking for when y is equal to 5? So that's the same thing as y is equal to 5. How can I use Desmos to help me find that? Because you can. Right. You're going to plug y equals 5 into Desmos, and you're going to find the points of intersection. And since they gave us the y value, what are we looking for? The x's. So we're going to use the x values. So if I do that, all right, I'm going to type in a separate bubble, y equals 5. It's all the way up here. And I'm going to look for my 2 points of intersection, which they do mark. There may be more than one point of intersection. Make sure you get all of them. So my answer is negative 1.18 and 2.38. So x is equal to 1.18 and 2.38, negative 1.18.
Oh, I get it now. So Whoa, Carson. That's rude.
All right, now why the heck are we doing this? Well, this is essentially the process of what you would be doing when you answer projectile motion questions. All right, so does anyone know what projectile motion actually is? So it's as an object falls due to gravity. It's a physics thing. The easiest way to explain a projectile motion is this. Everyone look at me. Look at me. Look at me. Look at me. Come on, look at me. Look at me. All right. Here's projectile motion. There you go. That's what it is. You'll launch something, then you goes up, come back in. Sure. Yeah. There you go. Yeah. So that's what projectile motion is. Now, a lot of the key features of it a lot of the key features from the graph can be synonymous to certain facts about the projectile motion. All right, so let's look at this first problem. So a ball is thrown straight up from the top of a 128-foot building. It has an initial speed of 32 feet per second. The height of the ball is modeled as a function of time and can be modeled by this function. So they actually gave us the function. And it asks, how long will it take for the ball to hit the ground? So before we do anything, let's just kind of draw a picture so we can model what's going on. So we got some building. And let's just say there's like this really itty bitty tiny dude up here, threw a ball. So it arced. So the ball's like right here. Comes down until it hits the ground. So here's the ground. All right. So that's kind of just modeling what's going on. You got your building. It's 128 feet. We threw the ball up, came down, hit the ground. Now, let's imagine that as a graph. So let's say that vertical red line that I just drew is the y-axis. And this vertical red line that I drew is the x-axis. So what axis is acting as the ground? The x. All right. So if it's asking how long will it take for the ball to hit the ground, what do you think I'm going to find? One of the zeros. All right. So in other words, one of the x-intercepts. So right here, that's an x-intercept. Now, specifically, which one do you think it would be? A positive one, if one's negative, one's positive. Or what direction? Would it be the left one or the right one? It would be the right one. All right. So let's put that function into Desmos. So I'm going to clear out everything. I'm going to type in, I'm going to replace t with x. So I have negative 16 x squared plus 32x plus 128. Now, it's going to look a little funky because you won't be able to see the full graph. If you want to be able to see the full graph, you can always change your window. How come it gave me what? That? So if I want to change my window so I can see the entire graph, it doesn't look like my x's go out very far. So I'm just going to let my x's go from, let's say, from negative 10 to 10. Let's actually make it 20. So negative 10 to 20. But it looks like that my y's go up for a while. But we only care about what y's. If we're talking about height, what's the only y's that we care about?
Positive.
The positive y's. So I'm going to make a really low negative y. So like, let's just say -1. And let's do -2, just so I can see the x-axis still. And I don't know how high the thing goes, so I'm just going to play with numbers. So I'm just going to try 5,000. All right, so it's still pretty high. So, and that's at 500. So let's do this about, let's call it 200. There we go. And I'm going to make this -5, honestly. Hit the wrench key in the top left, top right corner. Yes, sir. You could, but at some point it'll get so thin it'll just look like a straight line. It'll be really hard to see key features. I mean, you can, to each their own. I'm just saying if you want to actually see what it looks like, that's how. Yes, sir. How do you do the what? Question number 3. Well, we're not there yet. All right, so I'm looking for the positive value. So I have the 2 x-intercepts. Which one am I using? The 4. Why am I picking the 4 over the -2? What does x represent? In context of the problem, what does x represent? How many seconds? Can you have negative seconds? No. So that's the x-intercept. So this x-intercept is at 0.4. We use the x value. That's all you gotta do. Yes. You could have done what? Say that one more time. Guys, stop talking. That's more luck. But yeah, I can see that. Like physics wise, yeah. I would just use Desmos just to be safe. Yes. 2 times 2 what? All right. So, that is a very basic projectile motion problem. Let's try another one. So, a ball is thrown straight up from the top of a building that's 288 feet tall with an initial speed of 48 feet per second, and the height of the ball is modeled by this function. And it asks, when will the ball reach a height of 320 feet? So here's my question. 320 is not really any proper key feature, but there's something that we did up top, not in the previous problem, but when I had you guys find all those key features that we did that can help us find how long it takes for it to reach 320. What do you think that is?
2 seconds.
Well, what's the strategy? It's not the y-intercept. You said y equals 320, find the points of intersection. So we're going to plug in y equals 320 and finds the point of intersection. So I'm going to type in y equals 320. Well, I got to change my function first. That would definitely help. So that's 48. That's 228. So I'm also going to need to change my screen. So I'm going to go it out to about 500. It's 288. My bad. All right. So now I can zoom in a little bit. Now, if you look, it crosses in 2 different spots at 1 and 2. It's technically both of them, but if we were talking in context of the problem, all right, it's at 1 second when? So it's at 1 second first, but in context of the problem, like when you launch the ball, what's happening with the ball at 1 second? It's going up. All right. So that's when the ball's still going up. It hasn't started descending yet. 2 is when it's starting to fall. So I'm just saying because sometimes they do specify. All right. So you just need to understand that that's the context. All right. It's both. When will it reach the height of 3? So it'll be 1 second when it's ascending and 2 seconds when descending.
So in a test, a question like this, would you put 1 second or 2 seconds or what you just put?
You put both. So guys, it depends on how they word the problem. The way they word this problem, you can say both. But sometimes they ask like, how long will it take to reach this height after launched? It'll also say, or it'll say, how long will it take for it to fall to this height? Like you'll see different wordings for it. So you just gotta be careful. So after you start falling, that's the second one. And then after launch, more often than not, it's talking about before it hits the max height and starts falling. All right, now, a lot of times these key features can also apply to non-projectile motion applications. So that's where number 3 comes in. So it's not necessarily projectile motion, but it is a quadratic modeling problem. So the equation y equals x squared minus 12x plus 45 models the number of books y sold in a bookstore x days after an award-winning author appeared for an autograph signing reception. It asks, what is the first day that at least 100 copies of the book were sold? So first things first, we're going to graph the function. So I have x squared, what was it, minus what?
12x plus 45.
Plus 45. All right, I'm going to hit home just so I can zoom it out a little bit more. That's what it looks like. Now, it's obviously not projectile motion, but what's a good strategy that I can use to figure out the first day that I hit 100 copies? Y equals 100. So, 100 copies of the book sold. Well, Y is the number of books sold. X is the number of days. So we're finding X, but we're putting in Y equals 100 because it says at least 100. So as soon as it equals 100, we're golden. Yes, sir. So I'm going to type in Y equals 100. Now, there are 2 points of intersection here and here. Which is the only one that makes sense? The positive one, all right, because we can't have negative days. Now, here's my question. If we round to the nearest day, think about this carefully. It asks for the first day it reaches 100. Would I say 15 days or 16 days? Okay, here are a bunch of mixed answers. So who says 15? Raise your hand. Who says 16? All right. If you say 15, someone tell me why they think it's 15. Charlie. Right. So it's actually 15 because it's talking about days. All right. So 15 and a half, that means halfway through the 15th day, they reach 100 copies. So we would say 15 days. So typically when it comes to problems like these, more often than not, you end up rounding down, even though mathematically you would round that up. All right. It just depends on the context. Now, let's say you misrounded. I wouldn't kill you on it. All right. As long as you're within the margin of error. So like 15, 16, I would have accepted either one. Yes. Yes. So I would say after 15 days. Yes.
Ross, can you write my name on the board? You have to say it, please. Please. You have to say it.
All right. So just a summary of all the projectile motion stuff. All right. So this picture is also on the journal entry for projectile motion because it does a pretty good job of kind of summing up what's going on. So first off, this -0 right here. Obviously, it's going to get thrown out because it's negative, because time cannot be negative. So in reality, anything that has negative x values when it talks to projectile motion, you don't use at all. All right, you really don't start your graph till you're at the y-intercept, because the y-intercept talks about how high off the ground did the object start. So in layman terms, that's the initial height. So for example, in one of the previous problems, it said it was launched off a 128 tall building. That means that the initial height was 128, so that was the y-intercept, which we saw when we looked at the function. It was a c value. Now, the vertex shows you two things, depending on the value you're looking at. The x value of the vertex tells you when the ball reaches the max height. The y value tells you how high the actual object is, so the actual max height. So if you think about it as a point, the x value tells you the time that it reaches, and the y value tells you the actual max height. Now, the +0 or the positive x-intercept, so right here, that tells us when the object hits the ground. It also may be worded as how long is the object in the air. So there's two different ways that it may be worded. It means exact same thing. So when does the object hit the ground, or they may ask how long is the object in the air. Now, sometimes you have to plug in some stuff. So this one asks how high is an object after some number of seconds. All right. For that, you would type in Desmos, x equals some number, and then find the point of intersection. Specifically the y value. So let's say that I had a line that was how many seconds was going on. There's that point of intersection, and I would use the y value of that point. Now, it's not on here, but on the opposite hand, if it asks you how long to reach some number of height, all right, same thing, but you would use the y value instead. So you type in y equals a number into Desmos, and then find the point of intersection. And specifically, your answer will be the x value. And make sure that it makes sense in terms of context. So if I had that y value, it would be a horizontal line, two x-intercepts. In context, we would use the positive one. Does everyone understand the basic stuff that you would do in Desmos to find those key features? All right, last thing. So models. These are the stereotypical models for projectile motion. The only difference between the two is that this first one is in feet, the second one is in meters. Now, sometimes they don't give you enough information. They don't actually give you the full function. You have to actually input some things in it. So, just so you're aware, the B value of both of these, so it's B sub t, all right? That represents the velocity. Sometimes they may say speed, all right? So just know that the B value of the quadratic is typically the velocity, and they may sometimes say it's the speed. Now, we know that C value is going to represent what? What's that C value going to represent? The initial height. Here's my question. Does anyone know what those constants for the A value represent? Say it again. Wait, say it one more time. I can hear it. It represents gravity. Good. All right. So both of those constants represent gravity. In fact, it's half. Both those are half each the constant for gravity, depending on whether you're in feet or meters. So typically the constant for gravity in feet is 32 feet per second, whereas for meters it's usually 9.8 feet per second. That's usually the or meters per second, sorry. That's usually the constants for gravity. So they always use the half of it, but just know this represents gravity. Because it makes sense. Projectile motion, when it's launching, it's using that force that was used to launch it. But once it reaches its max, after that, gravity takes over. So that's why they half it, because gravity doesn't really affect it until after it starts falling. All right, so halfway up the graph. All right, last one we're going to do. So we're going to do this last problem. Walk me through what I need to do for each. So, yeah. So for some of these, you could just use what we already know about standard form equations. So like, if, for example, if you're trying to find the y-intercept, you can always just state the c value. You don't necessarily have to graph it. So a Dud missile is fired straight into the air from a military installation. The missile's height is given by this formula, where t is seconds and h of t is measured in feet. So first question, how high off the ground is the missile when it is fired? So what am I looking for specifically, like key feature wise? So how high is the missile off the ground when it is fired? So what am I looking for? The C value, which represents the y-intercept. So what will my answer be? 100 what? Feet. Gotta put units, guys. What was the missile's initial velocity? This one you have to get from the equation. So what value of the equation did I tell you represents velocity? The B value. So what would it be? 400 feet per second. Good. Yeah, that's fine. Now, it then asks, how high is the missile out of 4.5 seconds? So that one definitely needs to go in Desmos. But what are you putting in Desmos? Not y equals. X equals 4.5. So go ahead, put the equation and x equals 4.5 in. So put the original equation in, then put x equals 4.5 in, and find the point of intersect. So you're putting in the original equation, and then x equals 4.5, find the point of intersection. So it looks like you put in y equals 4.5. It needs to be x equals. Alright, so you might scroll up here. So, what'd you guys get? What'd you guys get? It doesn't have what? It should. Yep, so it should be 1576 feet. All right. The next question asks, what time will the missile reach its maximum height? And then what is the maximum height? So for both of those, I need to use the what? The vertex. Good. So for the first part of the question, what time will the missile reach its max height? What value of the vertex do I use? The x. So the actual maximum height, I use the y. So after how many seconds did they reach the 12.5? So it takes 12.5 seconds to reach a height of what? 2,600 feet. It then asks, what time will the missile land on the ground? So what am I looking for? The x-intercept, specifically which one? The positive x-intercept. So how long would it take? 25.35? 25. Yeah. So I think you would have to round it, just round it 2 decimal places, so 25.25 seconds. All right, last one. When will the missile be 2,500 feet above the ground? So this isn't a necessarily key feature, but what would I put in to Desmos? Y equals 2,500. Find the points of intersection. So I think there's 2 for this. Yeah. So what'd you guys get when you found the intersections? 10 seconds and 15 seconds. All right, and just so you're aware, it's ascending at 10, and it's descending at 15. Now, I don't necessarily need you to specify that on a test. I'm just making sure that you guys are aware which one's which. Yes, ma'am. Say that completely again. I absolutely cannot hear you over that fan. One more time. A multiple choice question. Yes. Question like this one? I know what. So do not see both of them. For the multiple choice question, they went out for 10, 15 different classes.
Another question.
So that. All right. Any questions on projectile motion? It's pretty easy, right?
Yes.
All right. You do got a delta math. All right. So your assignment is the 3.4 delta math. It's due tomorrow by midnight. Yeah. If you want to do test corrections during this time, that's fine.
Yeah, I got you.